Hello my dear students. So I'm going to continue with the extra questions. These are the MCQ type questions which I started in the previous chapter. So this is related to work, energy and force. Again to recall, work is when you apply a force and if you change the position of the object or if you change the shape of the object, we say that there is work done by the object or the work done by the force applied. And then the ability to do work is energy. There are different forms of energy. Under that we discuss mechanical energy. And under mechanical energy there are two main types or two types. That is kinetic energy and potential energy. Potential energy is the energy stored in an object due to its position or else due to its shape. Then the kinetic energy is the energy possessed by a moving object and it depends on the mass and velocity of the object. Thereafter we saw the power. Power is the rate of work done or work done in a unit time. And for both energy as well as work, the unit is joules. And for power, the standard unit is watts. So you can recall all what we have done before. So now we'll answer these questions. 11th one. Weight of an object is 50 Newton. What is the work done when it is lifted to a height of 2 meters? So this of course is a direct question. So there is an object that is being lifted to a height from this point to this point. So there the height is 2 meters and the force is given to you as 50 Newton. Now if they give you the mass, you need to calculate the force. But here already the force is given. So that includes mass into gravitational acceleration. So therefore work done is what? Work F into height. So that's 50 Newton into 2 meters. So that's going to be 100 joules. A direct calculation. So if we look at the answers here, 100 joules, 25 joules, 1000 joules and 10 joules. So the answer is going to be 100 joules. Here students, you all have to look at the unit. Normally they tell you a weight, the mass of an object. So there the mass is given in kilograms. So to convert it to weight, we multiply by gravitational acceleration 10 meters per second square. But here it is the weight that is given, 50 Newton. So that is mass into gravitational acceleration. That is the force exerted to lift the object up. So therefore you need to directly multiply by the height only. So this is the work done against the gravitational acceleration. So therefore the potential energy stored will be gravitational potential energy. So that's going to be 100 joules. Next one, unit of work done. Like I told you all, both work done and energy have the SI unit joules. So here work done, work and energy. They have the standard unit joules and power has the standard unit watts. So that is what you need to remember. Here unit of work done, what? No. Joule per second, that is equal to watts. Watts is equal to joule per second. Why? When 1 joule of work is done in 1 second, the power of the object or the machine is in watts. Then joules is energy, Newton is force. So Newton is force or weight. Force, weight, both are Newton. So the answer is unit of work done, joules. So I'm sure you have answered that correctly. Unit of work done, not watts. Watts is power. Joule per second is also power. Then joules is again work done as well as energy. This is going to be energy and work done. And also Newton is force as well as weight of object. Force is weight of object. Is that clear to you all students? So then we'll move on to the next question. That is question number 13. So like I told you all before also, if you haven't answered these questions. Now, when I change each of the slides, you all answer them first and then listen to my discussion. 13th one. The correct equation for kinetic energy when an object of mass m moves with a velocity of v. So, kinetic energy, you all can remember the direct equation, students. E kinetic equals half mv squared, because it depends on both mass and velocity, but velocity squared, half mv squared. So, if we look at the answers given to us, mv you know is momentum. Here if we write it, this is going to be momentum. Mass into velocity. Here of course half mv. There is no square there. V should have been v squared. Because of that it is not correct. Here of course half mv squared. That is correct. 2mv, that is also not correct. Because mv is momentum, but 2mv it's just a value, not relevant to kinetic energy. So the answer is half mv squared. Then the next one. A person does 600 joules of work in 1 minute. What is the power of the person? Again, power is what? Power, work divided by time. So, work done is how much? 600 joules. Time is 60 seconds. 1 minute, I told you all before also, students. You can write it as 1 into 60, or you can leave out the 1 because you all know 1 minute is 60 seconds. So directly you can calculate 600 divided by 60, 10 joules per second. That is equal to 10 watts. Joule per second is going to be equal to watts. That is the standard unit. Watts is the standard unit of power. So if we look at the answers, 600 joules per second, no, the value is incorrect. 100 joules per second, that is also incorrect. 10 joules per second, that is correct. So here they have used this particular unit, joules per second. So you have to remember, you should know the standard unit as well as other units as well. So here joules per second is power. Then 60 joules per second, that is also not correct. So 10 joules per second is the correct answer. I am sure you all can understand that, students. So then I'll move on to the next slide. There is a granite stone at the top of a rock. What is the energy stored in the stone? So when we say at the top of a rock, what does it relate to? There is a certain height. It is high above from the normal ground level. So due to the position, what is the energy stored? That is going to be potential energy. To be exact, gravitational potential energy. If we look at the answers, potential energy, it is correct, but you have to check all the answers. Kinetic energy, that is the energy possessed by an object when it is in motion, a moving object. So that is not relevant here. So here, like you all can see, students, gravitational potential energy, elastic potential energy. Both of them are types of potential energy. Out of that, you can remember, students, the question, most suitable answer. Now, potential energy is also correct. If they have not given gravitational potential energy, you can select potential energy. But since they have given gravitational potential energy, that is the most suitable answer, not elastic potential energy. So the answer should be gravitational potential energy. Is that okay? So then, 16. Kinetic energy of a moving object of mass 40 kg is 500 joules. What is the velocity of the object? So to do that, what do we need? We need the equation E kinetic equals half mv squared. So kinetic energy is given to you as 500 joules. You have half, mass is 40. We need to find v squared. if you rearrange, V squared is equal to 500 into 2 divided by 40. So that is going to be, you can simplify 2 and 40, 20, then 250 divided by 2, 25. So if we are to calculate V, that is root of 25, you all know is equal to 5 meters per second. That is the velocity, 5 meters per second. If you look at the answers, what is the velocity of the object? 25 meters per second. That is this answer. That is V squared. So you all have to be careful again, students. When you come to this point, you should not stop the calculation. You have to find V. V is found by taking the square root of 25. So here 5 meters per second, that's correct. 12.5 meters per second, no. And also 1.25 meters per second. That is also incorrect. So out of all these answers, 5 meters per second is the correct answer. This one, 5 meters per second. With that, students, I'm going to move on to the next question. Shown below is the motion of a ball suspended from a rod. So here you can see the motion of the ball. If we try to recall what is happening there, you can see this is the support. From there it is suspended. So normally the weight will be acting downwards, that you know. So there is equilibrium. If the ball is stationary, weight will act downwards, the tension will act upwards. So you remember the equilibrium of forces. But here the ball is moving. So then what happens? And from here to here, there is an energy conversion of kinetic energy to potential energy. Why? There is a velocity here. With the velocity, it's going to move up. So there's going to be E kinetic here. When it goes there, it becomes E potential. And at this point, E kinetic is going to be 0. Why? When it reaches this height, the velocity becomes 0. Because the velocity is 0. That is why it returns back in the same path. So again, when it is coming from there to here, potential energy will be converted to kinetic energy. So then on to this side, again kinetic energy. At this point, velocity 0. So it's going to be E potential. So they are also E kinetic to E potential. From there to here, E potential to E kinetic. So you're familiar with this type of motion. When height increases, kinetic energy decreases, potential energy increases. So the kinetic energy is transformed into potential energy. When it is moving downwards, the stored potential energy is transformed into kinetic energy. That is how the energy transformation occurs. You have discussed similar examples in your textbook. So you have to relate it to this example. So here, if we come back to the question, potential energy is minimum at. So if you remember what I told you all, here and here, it is the maximum potential energy, that is C and B. But at point A, that is the lowest position, there the potential energy is minimum. Or you can say 0. That is, if you ignore the height from the ground level to the point where this is hanging, it will be 0. But if there is height, there is a minimum potential energy. When the ball is moving this way, this is the point where there is the minimum potential energy, because there is maximum kinetic energy there. That becomes the potential energy at both points B and C. So potential energy is minimum at point A, yes. Point B only, no. Point C only, no. Points A and B only. That is also not correct. It has to be point A only. So it is minimum at point A only. Then the 18th question, kinetic energy is the maximum at. So that is also same. When potential energy is minimum, kinetic energy is maximum. Again at point A, kinetic energy is maximum, but in points B and C and B, you can see velocity 0, so kinetic energy 0. So kinetic energy is the maximum at point A only. Point B only not correct, point C only not correct, and points B and C only, that is also not correct. It is point A only. Is that clear, student? When potential energy is minimum, kinetic energy is maximum. So both those are seen at point A. At point B and C, potential energy maximum, kinetic energy 0. Why? Velocity is 0. I'm sure you all can remember that. With that, we'll move on to the next slide. Number 19. Mass of the ball is m and the vertical distance between points A and B is h. So the same diagram, you can see the mass of the ball is given to us as m and the height is marked here h. Gravitational acceleration g. Gravitational acceleration g. Then potential energy gained when the ball goes from A to C. That is the height difference. What is potential energy? E potential equals mgh. So here also they have used the same symbols. M is the mass, g gravitational acceleration, and h height. So E potential is equal to mgh. That is the answer we need to find. First one, mh, mass into height. It is not correct. Mgh, yes, it is correct. Mg divided by height, that is also incorrect. Mh divided by g, that is also incorrect. So it should be mgh. Potential energy, the potential energy gained when the ball goes from A to C. That is mgh. Is that clear to you all, students? So then we'll move on to the next question. Question number 20. Potential energy gained by an object of mass m when raised to a height of h is E. So they have given the values. What will be the potential energy gained by an object of mass 2m when raised to a height of h? So to do this calculation, you all know the equation for potential energy. E potential equals mgh. So the first object that has a mass of m, if we use the equation, they have given you the potential energy as E, that is equal to mgh. G is gravity, that is a constant value. Now let's say we will consider the potential energy of the object with mass 2m as E2. So if I write it as E2, that is going to be equal to 2m. Why? The mass is double now. Into gravitational acceleration into h. Now can you all see the relationship here? This is mgh, this is 2mgh. So what is the relationship? If mgh is E, 2mgh should be 2E. That will be the value of the potential energy when the object has a mass 2m. So from this, we can get the equation E2 is equal to 2E. By looking at the values itself, you can get that. Otherwise, if you divide 2mgh by mgh, this is E, you will get it as 2E. Is that clear to you all? I'm sure you can understand that. So, the potential energy gained by an object of mass 2m when raised to a height of h is going to be 2e. So, that is the answer we need. E not correct, 2e correct, e by 2 not correct, and 4e also not correct. So, it should be 2e. Then the next one. An unbalanced force of F is applied to a stationary object of mass m as shown below. What is the work done when the object moves a distance of s? So if we look at the diagram, here see the mass is given to us as m and there is a force applied F. Due to that force, the object goes to that position and the distance moved is given to you all as S. And they want you to find the work done. So what is work done? Work done equals force into displacement. What is displacement? Distance moved by the object in the direction of the force. So here, what is force? They have given it as F. And what is the distance moved by the object? That is S. So Fs is the work done. We need to find that answer here. Ms? No. Mass into distance moved. That is not correct because you need to have force, that is weight. So Ms is not correct. F into m, that is force into mass, that is also not correct. Fs, that is correct. Force into distance. F divided by s, that is capital S, that is also incorrect. So here it is Fs. That is the correct answer. I am sure you all can understand these two questions correctly, students. So then I'll move on to the next question. Question number 22. An object of mass 4 kg is suspended from a string. The object is lifted by 2 centimeters. What is the potential energy stored in the object? Here gravitational acceleration is given to you as 10 meters per second square. So then if we represent that diagrammatically, now there is an object hanging from a string. So let's say this is the object hanging from the string. So there is the weight acting downwards due to the gravity. But what they do is they lift the object up by 2 centimeters. So from this position, the object comes to a different position. So when it goes up, there will be potential energy gain. What is the equation for potential energy? EP is equal to mgh. So there we need the mass of the object that is given to us as 4 kg. So 4 into gravitational acceleration is given to us as 10 meters per second squared, 10, and h, this is in centimeters. So can we use it in centimeters? No, we need to convert it to meters. So 2 centimeters divided by 100. Then of course you will get the answer as 10, 100 you can simplify. So 8 divided by 10, 0.8 joules. 0.8 joules. That is the answer. So as you can see, the mass of the object is 4 kg, gravitational acceleration 10. Since the height lifted is 2 centimeters, we need to convert it to meters. So when you divide it by 100, you get the answer as 0.8 joules. So we need to find the answer here. 80 joules? No. 8 joules? No. 800 joules? That is also incorrect. It should be 0.8 joules. 0.8 joules. Is that clear, student? So that is the answer there. Then the next one. 23. What is the work done in 5 minutes by a machine operating with a power output of 200 watts? So what is the equation? Power equals work done divided by time. So if you want work done, you need to multiply power by time. Power by time. So there. What is the power? They have given it as 200 watts. 200 watts. And time, you can see 5 minutes. So what should be the unit of time? It should be in seconds. So here 5 into 60 seconds. Here of course you have to write 5. If it's 1 minute, I told you all, you don't have to. It is not a must to write the 1 minute. So you can directly write it as 60 seconds. But since this is 5 minutes, you have to multiply by 5 into 60. You have to show the multiplication. So then you will get the work done. 200 into 5, 1000. 1000 into 60, 60,000 joules. Watts into second is joules. You can remember watts is joules per second. So watts into seconds, the answer will be in joules. So the work done is 60,000 joules. So we need to find that answer. Power output is 200 watts. Time is 5 minutes. So they want us to find the work done. 1000 joules? No. 12,000 joules? That is also not correct. 60,000 joules correct. 40 joules incorrect. So the answer is 60,000 joules. Is that okay, students? So then I will move on to the next question. A person with a mass of 45 kilogram climbs up a staircase to reach a height of 4 meters. And the gravitational acceleration is given to us as 10 meters per second square. What is the potential energy gained by the person when he reaches the height? So there again we have looked at similar examples. You can remember, students, when a person climbs up a staircase, so although the staircase is going to be like that, it is the vertical height from here to here. That is important to us. So this is important. This is the vertical height. This is how he is going to climb the stairs. So if you look at the values, the mass of the person is 45 kilogram and gravitational acceleration is given to us 10 meters per second squared. So you all know, if a person has to climb up, the mass, the work is done against the gravitational acceleration. So to find the force exerted, what do? We need to find the weight. Weight equals mass into gravity. So that is 45 kilogram into 10 meters per second squared. So that's going to be 450 Newton of force exerted. And the person reaches a vertical height of h, but h will be given to us, that is given as 4 meters. So there, this is 4 meters. So what is going to be the work done? Work done is equal to 450 Newton into 4 meters. That is going to be 1800 joules. 450 into 4. 1800 joules. That is the work done. So if you look at the question, a person with a mass of 45 kilogram climbs up a staircase to reach a height of 4 meters and the gravitational acceleration is 10 meters per second squared. What is the potential energy gained by the person when he reaches the height? So what is the potential energy? E potential is equal to work done against gravity. That is what we calculated as 1800 joules. Is that clear to you all? So we need to find that answer. 180 joules? No. 1800 joules? Correct. 112.5 joules? No. And 450 joules? That is also incorrect. So it should be 1800 joules. Then the next question. What is the work done by the person when climbing the stairs? The same thing. Work done is the gravitational potential energy gain. So we calculated work done and that became the gravitational potential energy. Or you can do it the other way. It's the same thing. E potential is equal to mgh. So even if you use that equation, E potential equals mgh. The same thing. Mass is 45, G10 and 4. So that also will be equal to 1800 joules. Either you calculate the work done and find the potential energy, or you find the potential energy, calculate the work done. It's the same thing, the same value, because what you do as work against the gravitational acceleration becomes the potential energy. So the answer should be 1800 joules. 180 joules? No. 1800 joules, that's correct. 112.5 joules incorrect, and 450 joules also incorrect. I am sure students, you all have understood this clearly and answered these questions correctly. So then we'll move on to the next slide. Question number 26. What is the term used to identify the ability to do work? What is the ability to do work? That is energy. Energy is the ability to do work. There are different forms of energy like sound energy, light energy, heat energy, mechanical energy, electric energy. All these different types of energy help us to do work in our day-to-day life. And under that, we have discussed potential energy and kinetic energy in detail. So the ability to do work is energy. What is the term? So here you can see what is the term used to identify the ability to do work. Force. What is force? Push or pull. Power. Work done in a unit time. Energy is the ability to do work, and friction, you all know, when there are two surfaces in contact with each other and when one is trying to move respective to the other, the force exerted against the motion to prevent the motion or against the motion is what we call as friction. So here the answer relevant to the question, what is the term used to identify the ability to do work, is energy. Then the next question, question number 27. Select the true statement from below, correct statement or true statement. Kinetic energy. So when we say kinetic energy, what do you need to remember? True statement. Kinetic energy, E kinetic, half mv squared. So this is the energy possessed by an object due to its motion. And it depends on two factors, mass and velocity of the object. So kinetic energy increases when the mass of an object increases. Kinetic energy increases when mass of an object increases. Why? E kinetic is proportional to mass. That is correct. Second one, kinetic energy increases when the mass of an object decreases. That is incorrect. Because when mass increases, kinetic energy increases. Kinetic energy increases when the velocity of an object decreases. That is also wrong. Here you can see v squared. So when velocity increases, kinetic energy will increase. So this is also incorrect. Kinetic energy does not depend on the mass of the object. That is also incorrect. Why? Here in the equation we have mass. So this is also incorrect. So the correct answer or the true statement, kinetic energy increases when the mass of an object increases. That is the correct answer. So that is the true statement. Is that okay, students? So then I'll move on to the next question. 28. The figure shows how three objects of equal mass are placed at different levels. the object with the highest and lowest potential energy respectively are. So let's look at the figure. Here you can see this is the figure. So objects A, B and C. A, the distance is 2 meters, then 3 meters, and this is the shortest 2.5 meters. So what will happen? They have said 3 objects of equal mass. So E potential, you can remember M, G, H. So these two are same for all 3 objects. Mass is the same, gravity is constant. So the potential energy will depend on its height. So the shortest height is C. So that will have the lowest potential energy. The maximum height is 3 meters. 0.5, 2 and 3 meters. So B will have the highest gravitational potential energy. C has the lowest gravitational potential energy. B has the highest gravitational potential energy. If we look at the question and the answers, you can see the object with the highest and lowest. Highest is what? Highest is B. Then we have lowest C. So highest and lowest potential energy respectively are A and B not correct, B and C correct, C and A not correct, and C and B also not correct. Because C has the lowest and B has the highest. It should be B and C, highest and lowest. The order should be correct. So that is how we answer this question. Then the 29th one. 250 joules of work is done when an object was displaced by 5 meters in the direction of the unbalanced force. What is the magnitude of unbalanced force? So what happens here? We have an object. It's initially here. Then it moves to a position like that. So during this time, 250 joules of work is done. This distance is 5 meters. We need to find F, the force applied. So how do we do that? Work done, force into displacement. So work done is given to us as 250 joules. That is 250 joules. Force is F into distance moved by the object, that is displacement 5 meters. If you rearrange 250 joules divided by 5 meters, that is going to be 50 Newton. 250 divided by 5. 50 Newton. Joules is what? Newton meters. So Newton meter divided by meter, you get the answer in newtons. 50 newtons. That is the answer. So what is the magnitude of the unbalanced force? 1250 Newton. That's incorrect. 0.02 Newton. That's also incorrect. 50 Newton, that is correct. 5 Newton is also incorrect. So it is 50 Newton. Is that okay, students? So then we'll move on to the next question. Question number 30. So here, if we look at the question, what is the power exerted when an object of mass 60 kilogram is displaced by 5 meters in 20 seconds? So there, if we show it in a diagrammatic manner, you have a path like that. So there is an object that is being displaced. So what is the power exerted? This has a mass of 60 kilogram and it is displaced by a distance of 5 meters. Time taken is 20 seconds. Now here you can see it is the mass of the object that is given to us. So if you want to push it, what do you need to do? You need to apply a force. So that will be equal to the weight of the object. That is what you need to calculate first. So we need to calculate weight of the object. Weight of object 60 kilogram into 10 meters per second squared. That is going to be 600 Newton. Now students, so far I have been writing all the equations in complete equations. Here you all know when we say mass of weight of the object, mass into gravitational acceleration, that is 600 Newton. So force exerted, force is 600 Newton. Then work done. Work done, force into displacement. That is going to be 600 newtons. Here you can see the distance moved by the object or the displacement is 5 meters. So 5 meters. That is going to be 0. So 3000 joules. Newton meters, that is equal to joules. But they want you to calculate the power. Time taken is 20 seconds. So there. Power equals work done divided by time. So that is going to be 3000 joules divided by 20 seconds. That will be 150 joule per second, or we can say 150 watts, depending on the unit given to us. Now here students, you don't have to write all these steps and do this calculation if you are going to answer the MCQ. You can directly do the calculation without writing all these equations. But you have to make sure that you find the weight of the object, that is the force done, then you calculate the work done, and finally you calculate power. For a question where you have to write the answer, you have to show all these working. But for an MCQ, as long as you know the steps, you don't miss out any steps, you don't have to write everything. But for you all to understand clearly, I have shown all the workings with the equation itself. So if you go back and check, this is what happened. A 60 kilogram object moves a distance of 5 meters in 20 seconds. They want you to calculate the power. So weight of the object is 60 into 10, that's 600 Newton, that is the force exerted. So work done is force into displacement, that is 600 into 5, that gives you a value of 3000 joules. Then if we calculate power, work done divided by time, 3000 joules divided by 20 seconds, you get the answer as either 150 joule per second or 150 watts. So that is the answer that we need to find. So here 120 watts, 60 watts, 15 watts and 150 watts. 150 watts is the correct answer. I am sure students, you all also did this calculation correctly and underlined the correct answer. So far we have discussed in the previous chapter and this chapter 30 questions. Those are multiple choice type questions where you needed to underline the most suitable answer. And I am sure you were able to do that correctly. So with that, I am going to end this chapter, and in the next chapter, I will be discussing some more extra questions with you.